Applications with equations. Let's begin. The problem group 6 was faced with is a man launches his boat from point A on a bank of a straight river that is 3 kilometers wide and directly across from point X. He wants to reach point B, which is 8 kilometers downstream from point X, as quickly as possible. He needs to row across the river to point C and run the rest of the way to point B. He can row 4 kilometers per hour and run 6 kilometers per hour. So the questions that we need to figure out are, first, we need to write a function to model the time it will take him to reach B as a function of D. Second, through the function, we need to find the minimum time it will take to reach point B from point A. And to make sure our function works, we need to figure out how far downstream he needs to row if he wants to take a 2-hour trip to point B. The variables of this equation will be distance as the independent variable and time as the dependent variable. This is the diagram to solve our problem. So it is determined from the problem that the river is 3 kilometers wide, which is represented by points A and X. The man needs to row from point A to C, then run from point C to B. It is shown that A, X, and C are all connected to form a right triangle. We know he runs at a rate of 6 kilometers per hour and rows at a rate of 4 kilometers per hour. A key equation or key equations needed to make our function are the Pythagorean theorem and the distance formula. In the problem, it states, or we know, that he runs at a rate of 6 kilometers per hour and rows at a rate of 4 kilometers per hour. To find our function, key equations needed are the Pythagorean theorem and the distance formula. Because AXC is a right triangle, we can use the Pythagorean theorem to find distance AC. So through the Pythagorean theorem, we arrive at d squared plus 3 squared equals c squared. And through algebra, we know that c equals positive the square root of d squared plus 9. And we know that d squared plus 9, or the square root of d squared plus 9, has to be positive because it is impossible to have a negative distance. A key equation we need to find for our function that we need to find is the distance formula, which is distance equals rate times time. Because we are solving for time, we have to rearrange our formula so time equals distance over rate. And where our distance and rate, we can replace our variables with the actual distance and rates that we have from the problem. For our rowing component or rowing equation, distance, we replace d with the distance, which is positive the square root of d squared plus 9, and rate is 4 kilometers per hour. For our running component, we replace d with our distance, which is 8 minus d, and our rate, which is 6 kilometers per hour. In order to find our total time, we need to add together our rowing and running equations. Once you do so, you arrive at T of d equals positive the square root of d squared plus 9 over 4 plus 8 minus d all over 6. Now that we have figured out our function, we need to answer the question, what is the minimum time it will take to reach point B from point A? To do so, we are going to use the calculator to find our answer. Enter the new function in the calculator in the y plot. If you do not have a TI-84 plus Silver Edition, be careful when using parentheses. Before graphing, we must restrict our domain and our range by pressing the Y button on the calculator. For our X minimum value, we know that time cannot be negative, but you also want to still be able to see your Y-axis, so we're going to use the numerical value -2. And for our X maximum, we know from the problem that the river or the distance needed to travel is 8 kilometers, so we're going to use the value of 8. For our Y minimum, we know that time cannot be negative, but you still want to see the X-axis, so we're going to use the numerical value -2 once more. And when doing this problem, we guessed that the trip should not take more than 3 hours, so our Y maximum was made 3. And for the X scale and Y scale, we use 1. Do not change that. To find the minimum point, press second, then calculate. From there you go and press minimum. When finding the minimum, the calculator will ask for left and right bounds. For the left bound, just go far enough left so you're not on the minimum point. And for the right bound, go far enough right so you're not on the minimum point. Once you do so, hit the calculator 3 times because it will ask you for a guesstimate. But once you hit it the 3rd time, it will give you the answer of 1.89 hours at a distance of 2.68 kilometers. Now that we have found the minimum time it takes him to reach point B, we need to find how far downstream should he row if he wants the trip to last 2 hours. To find how far downstream he should row, we are going to go back to the Y plot and enter 2 in the second Y place below our function. This will help us find the intersection between the 2 functions and find how far he rows at 2 hours. Keep the same window and press second calc and go to intersection. Go to the point of the intersection and press enter 3 times. When you're finding the intersection, you have to be careful because line 2 intersects our function twice. So there are 2 possible answers varying on the amount of running and rowing. If he wants the trip to last 2 hours, he can either go 0.584 kilometers of rowing or 5.81 kilometers of rowing.
That's all, folks. Thanks for watching.